Greetings, this is Greg. The F4U Corsair is probably the most easily recognized plane from World War II. None of its external features are particularly unique. The long nose, inverted gull wings, and the forward location of the vertical stabilizer can be found on other airplanes, but no other airplane has all of these distinctive features and not to the same degree. There are specific reasons for each of these things. And there are quite a few other unusual features about the Corsair that a lot of people don't know about. I plan to cover these subjects in this video. I'll probably keep this video pretty light on technical issues since my previous airplane video and my next one will be very tech heavy. I'll be focusing on the World War II Corsair variants, mostly the earlier Dash 1s, but many of the pictures will be used from later variants. Externally, they look almost the same. So let's get started. One unusual fact is that the F4U Corsair has aluminum armor in addition to its steel plate. Normally, aluminum won't do much to stop a bullet unless it's too thick to be realistically used in an airplane. But this wasn't normal aluminum. It was an aluminum and copper alloy that was made with a special procedure making it very hard. This alloy was invented by a German named Alfred Wilm in 1903. It was called duralumin, or more often in U.S. technical manuals it was called Dural. The Germans didn't keep this new discovery a secret. Why would they? Nobody was taking the idea of military airplanes seriously in 1903. But by 1916, they started using it in airplane structures. During the heyday of the great airships, it was used in the frames of these giant vessels, including the Graf Zeppelin, USS Los Angeles, and probably any other airship you've ever heard of from that era. Fast forwarding a few years to World War II, and the U.S. started using it as armor plate. Now, it wouldn't stop a 50 caliber or 13 millimeter bullet, certainly not one fired from close range at a steep angle, but it would deflect bullets coming in at a shallow angle relative to the armor, 30 caliber or 8 millimeter bullets anyway. In the case of the Corsair, they used this thick plate on the upper cowl deck above the fuselage tank. The fuselage-mounted fuel tank in the Corsair is self-sealing, but there are limits to everything, and some extra armor here is probably a good thing. Getting off topic for a moment, Dural was not unique to the Corsair. The Douglas A-26 Invader also used it. The A-26 Invader, not to be confused with the B-26 Marauder, was quite advanced. The Invader had heavy steel plate protecting the crew, but it also made tremendous use of Dural to protect the cockpit from bullets coming in at shallow angles. Notice the Dural plate under the engine cowlings. You might wonder, what are they trying so hard to protect there? In fact, let's look at the steel plate again for a moment. Notice this area is fortified fore and aft with steel plate. Back to the other picture, and you can see that it has Dural below. That armor is there to protect the propeller feathering pump. It's not there to protect the A-26 from losing an engine. You couldn't possibly add enough armor to do that. It's there to ensure that if an engine is lost, the pilot will be able to feather the propeller. To understand this, let's have a quick look at this RAF Mosquito that returned from a mission with an engine out. Note that the aircraft's left propeller blades are turned so that they show a minimal profile to the oncoming air. This is what's called the feathered position, and it's the position you want the propeller in if you've lost the engine. A propeller that's not feathered will windmill and cause a huge amount of drag, so much so that in most cases the plane will not be able to hold altitude with the power from the remaining engine. Thus, if enemy fire knocks out an engine and the feathering pump, typically the remaining engine will only serve to carry the plane to the crash site. To protect against this and improve the odds of getting the plane home in this situation, they protected the feathering pump with armor. I know we've gotten a bit off track here, but as long as I brought up the A-26 Invader, let me mention a few more things about it. I think it's a very underrated airplane. It had a lot of firepower, advanced gun turrets, a lot of armor protection, a laminar flow wing with dual slotted flaps, and it's powered by twin R2800 engines with dual speed superchargers and water injection, putting out 2,370 horsepower each at war emergency power. It carries a greater bomb load than most medium bombers, and has a top speed of 355 miles per hour, making it difficult to intercept. In over 11,000 missions in Europe, only 67 A-26s were lost. Back to the Corsair, one last thing about armor. It appears from diagrams that the later Corsairs had additional Dural plate, but I can't confirm that. If anyone has source data on that other than this diagram, I'd love to hear about it. Let's talk about that long nose. Originally, the Corsair's cockpit was located conventionally. Due to a pre-production armament change to 6 wing-mounted 50 caliber machine guns combined with the wing folding mechanism, there just wasn't enough room left in the wings for large fuel tanks, and the Corsair's R2800 engine needed a lot of fuel. Since both fuel and self-sealing tanks are heavy, the tank needed to be located over the plane's center of gravity for balance reasons. The only way to do that was to put it about where the pilot sat and move the whole cockpit back, so that's what they did. This seemed to be a decent solution, but then the U.S. Navy found that the decrease in forward and downward visibility made the plane just too difficult to land on carriers, and they rejected it for carrier duty, limiting it to land-based operations, mostly with the U.S. Marines. This was probably a huge blow to the Corsair design team. A lot of the expense and the design of this plane revolved around its wing folding mechanism, which was very strong and hydraulically operated. Limiting it to land-based operations negated some of the big features of the Corsair design. Nevertheless, the plane did do extremely well as a land-based plane, but then, on the other side of the world, something happened. The British figured out that the Corsair could be landed on a carrier by flying a curved approach so as to keep the deck and landing signal officer in view just forward of the inboard section of the wing. This wasn't ideal, but it was still difficult, but it was doable, and the Corsair's ruggedness and performance made it worth doing. The British carriers made a significant contribution to the war effort in the Pacific during the last 15 months of the war. The exploits of the British fleet in the Pacific are rarely discussed, but were significant. Even the British themselves seemed to forget about this part of the war. When the sailors from the British Pacific Fleet went home, they often found that their countrymen didn't even know about the war efforts of the Royal Navy in the Pacific, and worse, the British Pacific Fleet wasn't even represented in the London victory celebrations of 1946. The fleet was one of the largest ever and contained 6 fleet carriers and 4 light carriers and quite a few smaller carriers. On board these 10 main carriers, the Corsair was the most common fighter by far. Only 1 carrier was equipped with Hellcats, 2 with Seafires, the rest had Corsairs. I realize I'm straying off topic a bit here and into subject matter outside the usual scope of my channel. So I'll just add that the British Pacific Fleet engaged in many important battles, including attacks on mainland Japan, Okinawa, and in naval engagements against Japanese carriers. The British carriers and their Corsairs did really well. Even when the kamikazes reached the carriers, they did minimal damage because, unlike the U.S. Navy, the Royal Navy had armored flight decks. After the war, the fleet stayed in the Pacific and performed humanitarian duties. That's all I have to say on this topic, but I would like to see someone with a more historically oriented channel tackle this in more detail. Military aviation history and military history visualized both come to mind, as both are good channels in a field where many are not. So, we've covered a few of the Corsair's oddities, like aluminum armor, the long nose, the resulting difficulties with carrier landings, but there are a lot more unusual features. The Corsair has dive brakes. The designers wanted it to be effective as a naval bomber, and at the time, dive bombing was the only form of bombing proven accurate enough to reliably hit ships maneuvering at sea. However, they couldn't put in conventional wing-mounted dive brakes, as seen on this Dauntless here, because the Corsair's wing had other higher priority design requirements. So the designers of the Corsair used short and very strong main landing gear to do double duty as dive brakes. By using the dive brake control in the cockpit, only the main landing gear will extend and the tail wheel stays retracted, since the tail wheel and related doors would suffer damage at higher speeds. When using the dive brake control, the main gear could be extended at speeds up to 225 knots indicated. Once extended, the plane could dive at steeper angles at a given speed than it could with the gear up. Continuing on with the gear, the Corsair is one of the first planes to have its main gear fully enclosed when retracted, certainly the first U.S. Navy plane. Even typical land-based airplanes like the P-40, Bf-109, and Spitfire didn't have that at the time the Corsair entered service. Let's talk about the tail. The vertical stabilizer is located really far forward on this plane. Some other planes are that way. The de Havilland Mosquito is one. And it's common, although to a lesser degree, on some modern airliners. I don't have a specific source for this related to the Corsair, but normally tails are built this way for structural and not aerodynamic reasons. Pretty sure that's what's going on here. The vertical stabilizer via the rudder puts a large asymmetric twisting load onto the fuselage. Thus, the vertical stabilizer has to be very solidly attached. The Corsair's fuselage tapers down a lot at the rear, and there isn't as much metal to attach to the farther back you go. Add to that the fact that the space back there is already taken up and the structure is compromised to some extent by the retractable tail wheel and arrestor hook. I just don't think they had enough solid structure back there for the vertical stabilizer. Of course, this isn't a problem for the horizontal stabilizer since it creates a symmetrical force on the fuselage and attaches to the structure and transfers its force very differently. Some modern airliners are a bit like this. They don't have retractable tail wheels or arrestor hooks back there, but they often have auxiliary power units in the tail and often have the vertical surfaces forward a bit. The Boeing 777 comes to mind. Let's go back to the fuel system for a moment. Most of the World War II Corsairs have two fuel tanks, one in each wing, each with a 62-gallon fuel capacity, in addition to the 237-gallon self-sealing tank in the fuselage. The fuel tanks in the wing are not self-sealing. Instead, they can be purged with CO2 prior to entering combat. This makes the atmosphere in the tank above the fuel inert. The system also purges the lines to the wing tanks. It does not remove the fuel in the wing tanks, so although the manual doesn't say this, I'm sure that once the tank is hit, after some period of time, if it gets hit again, that's not going to be so good. Of course, with an R2800 engine, you could probably use all that wing tank fuel up before you get into combat and then purge them, which is probably what happened more often than not. The fuselage tank is pressurized by supercharger boost taken from the intake manifold and passed through a regulator. This ensures that fuel pressure doesn't drop at altitude due to the formation of vapors in the tank. However, if the tank is hit hard enough so it doesn't fully self-seal and starts to leak, this system will force fuel out of the tank at an accelerated rate. Of course, we don't want that. So, to minimize leakage in this case, the pilot can shut that system off. Remember those CO2 bottles in the cockpit? Let's look at them again. World War II aircraft are typically really terrible in regards to ergonomics, and the Corsair is about average in this regard. It's certainly not great. This is a good example. It's possible when heading into combat and it's time to blow the CO2 into the wing tanks, you could finger fumble this and blow the gear down, even with the gear control in the up position. Once you do that, you can't bring it back up, and you're easy prey for enemy fighters. I read one account of a pilot being killed from this exact scenario. I think I read about that in the book The Jolly Rogers about VF-17 and Tom Blackburn. I know I read it somewhere. I'm just not 100% sure it was in that book. If anyone knows of that story and the source, please post that in the comments below. It's time to discuss the bent wings. Often these are called cranked wings or inverted gull wings. I consider any of these terms acceptable, although some people get quite hung up on aviation terminology. In nearly every single book or video on the Corsair, they tell you that the bent wings are there so that the propeller will clear the ground. That's not incorrect, it's just that it's really far from being complete. It's sort of a kindergarten level explanation, and one that is obviously incomplete because there are numerous planes that use the same engine and don't have bent wings. For example, the Hellcat and the Thunderbolt. They both use the R2800 engine, with propellers nearly the same size. The Hellcat's propeller is 1.5 inches smaller in radius, and the Thunderbolt's is only 1 inch less. In the case of the Thunderbolt, it used telescoping landing gear, which introduced complexity that the Vought designers didn't want in a naval fighter, so we'll use the Hellcat for a comparative explanation. Let's start by looking at the Corsairs Fuselage. Note that it's equally round, or I should say essentially round, until you reach the cockpit, and its diameter is about equal to the diameter of the cowling, again until you reach the cockpit. This is because the Vought engineers were really focused on performance, and they wanted the Corsair to be competitive with land-based fighters, and a part of that goal was to have a 400 mile per hour top speed. To help reach that goal, they wanted to keep the fuselage frontal area to a minimum. However, the R2800 engine, which they selected for this design, required oil cooling and intercooling, and lots of it. The normal solution for a radial engine fighter was to locate at least some of those components or their related intakes for ducting at the front of the fuselage. Let's take a look at the Grumman F4f Wildcat here. Its landing gear and intercoolers are located in the fuselage, which contributes to its girth. By the way, notice the mid-mounted position of the wing. Better yet, notice that the wing is mounted to the fuselage just about in line with the propeller spinner. That's going to matter later. Now, Vought didn't want to do it this way. They didn't want a fat fuselage. So they located the inlets for the oil coolers, as seen here, in the inboard section of the wing's leading edge. These inlets also send air to the intercoolers, which are not shown in this picture. Now let's take a look at the Hellcat. The Hellcat, which is in the foreground, has wing-mounted landing gear, and to help it reach the ground, look how far down the wing is mounted relative to what we saw on the Wildcat. It's about in line with the bottom of the engine. The fuselage area below that line is for ducting and coolers. Add in the fact that the Hellcat's gear is much longer than the Corsair's, and the prop has a 1.5 inch smaller radius, and we can see why it doesn't need bent wings. Note the Bearcat in the background has telescoping gear like the P-47. I suspect the shorter gear in the Corsair was a lot stronger than the Hellcat's. Its extension speed is certainly much higher, 200 knots for the Corsair and 225 in dive brake mode, versus only 135 knots for the Hellcat. Those limits are usually controlled by the extension system and not always the gear itself, but still it's a huge difference, and the Hellcat's gear does not do double duty as a dive brake. I watched quite a few carrier crash landing videos, and I didn't find a single one where a Corsair's landing gear broke off. Of course, the Hellcat served on carriers earlier, so it could just be that there are more videos of the Hellcat, but still, I found quite a few videos where the Hellcat's gear broke, and often where the fuselage broke somewhere after the cockpit. In similar crash landings with the Corsair, I never once saw broken gear, and the plane seems to hold together really well. The Corsair's fuselage doesn't have enough girth to mount the wing low enough for the gear to reach the ground, at least not if it's going to be short enough to retract into the existing wing and double as a dive brake. However, there is another issue, and it's related to speed. There are different types of drag that affect airplanes, and one is called interference drag, and it's a big factor. I've referenced the Pilot's Handbook of Aeronautical Knowledge here. It's extra drag caused by the joining together of two surfaces, like everywhere the fuselage connects to something else, wing or tail component. NACA did many studies on this and found that the area where the fuselage joins the wing root is a significant source of interference drag. They tested various points of attachment and found that a wing that joins the fuselage at about a 90-degree angle is about ideal. If the Corsair had a straight wing that joined the fuselage at that angle, it would be mounted about in line with the propeller spinner, much like what we saw on the Wildcat. Imagine how long the gear would have to be then. So by using the bent wing design, they could not only have the propeller clearance, they could do it without the telescoping gear. They could do it and still keep the fuselage frontal area to a minimum and reduce interference drag. So it's not entirely correct to dumb this whole thing down and say that the bent wings were just so the propeller would clear. They could have solved that with telescoping gear, but that would have added complexity. and sacrifice strength and the dive brake capability of the gear. They could also have solved it with a fatter fuselage combined with longer gear, but that would have sacrificed the gear strength and slowed the airplane down. The bent wing created enough propeller clearance without sacrificing gear strength or speed, and that's the point of the design. Of course, the extra complexity of the wing design offsets the gains a bit, but overall it results in a net gain, which is why they did it. All of this enabled the Corsair to exceed its design goals and have a top speed in excess of 400 miles per hour. And below 20,000 feet, it was competitive with land-based fighters throughout the entire war. Once the U.S. Navy started putting Corsairs on carriers, they became the dominant fighter in the U.S. Navy. The plane stayed in production until 1953, making it the last of the World War II naval fighters to be produced, even outlasting the Bearcat. I have one last thing to mention. The Corsair went on to have a long military career and ultimately scored the last air-to-air kills by a piston-engine fighter. This happened in 1961 when a disagreement over a soccer game. I'll back up for a moment. Soccer is a British word for association football. I'm not quite sure how you get the word soccer out of association. I think it might have something to do with warm beer and Lucas Electronics. But in any case, in some parts of the world, they call this sport soccer football, but it's not what we in the U.S. call football, so it gets a bit confusing. Regardless, apparently some people in Central America are really into this sport, and a disagreement over one of the games set off a short war in which both sides were flying U.S. World War II airplanes. The Corsair came out on top, with one scoring 3 air-to-air kills, at least one of which was against a P-51. The Corsair pilot reported that he was able to easily outturn the P-51 and get the shot. So I hope you enjoyed this video. I know I got off topic a few times. I sort of avoided engine stuff and a lot of the NACA details just for a change of pace. The Corsair's R2800 engine could easily be a video all its own, so I largely ignored it in this one. My next airplane video will be very heavily biased towards engine technology in World War II. Hopefully, some of the information in this video is new to you. Let me know what you think in the comments section. Please like and subscribe for more. And thanks for watching and have a great day.